Welcome to our YouTube channel students, e-learning hub by Udgam Welfare Foundation. Students, in this video series we are discussing the case studies on continuity and differentiability chapter for grade 12 students, and if you have missed our previous case studies, then I request you to please watch those case studies, and it is going to help you out in understanding the various concepts of this particular chapter. These case studies are very useful whether you are a CBSE board student or whether you are an ISC board student. Now let's move forward and discuss our case study number 3. So students, here comes our case study number 3, which states Priya is analyzing the movement of a particle constrained to move along a path defined implicitly by the equation x square plus xy plus y square is equal to 7. She is curious to find how the position of the particle changes over time, particularly the rate of change of y with respect to x. This problem cannot be solved using explicit differentiation because y is not isolated in the equation. Priya uses implicit differentiation to find dy by dx. She also explores second order derivatives to understand the concavity of the curve. Additionally, she tests whether the function defined by the relation is differentiable at certain points by checking continuity and applying partial derivatives. Let's explore the mathematical implications of her analysis. Now, on the basis of this particular case study, we are going to discuss 5 MCQ as per the board standards. Now, let's move forward and discuss our first problem on this case study. So student, this is our first question on this case study. Given the implicit function x square plus xy plus y square is equal to 7. So what is dy by dx? Here we are discussing the implicit function, and implicit functions are those functions where you cannot separate the dependable variable from the independent variable. So dependable variable is mostly y. So here you can see that xy is joint here, and you cannot separate or isolate that variable. Now let's understand how to differentiate implicit function here. So here we need to find dy by dx. So first derivate this. So x square derivative is nothing but 2x. xy derivative is x into y dash plus y into x dash is nothing but 1 plus y square derivative is 2 into y dash, and the constant derivative is 0. Now here we are going to separate y dash terms. Now let's combine y dash terms first. So here we are getting y dash x plus 2y, and we can take other terms to the RHS. So this term is 2x, we can take it to the RHS, which is minus 2x. Then this term is also there, y into 1 is nothing but y, so minus y. So this implies y dash is equal to what? Y dash is equal to minus 2x minus y upon x plus 2y. So this is our correct answer here. Do we have this particular option in our answer? So minus 2x minus y and x plus 2y. So option number A is our correct answer here. Now let's move towards question number 2. So students, here comes our question number 2, which states for the same function, what is the slope of the tangent at the point 1, 2? So students, that was our previous question where we found that dy by dx equals to this. That means slope of this particular function was minus 2x minus y upon x plus 2y. Now we need to find the slope of this tangent at 1, 2. We simply plug in the values of 1, 2 here in our derivative. So we are going to get what? Minus 2 into 1 and minus 2 upon 1 plus 2 into 2, because we have the derivative this minus 2x minus y upon x plus 2y. We are simply plugging the value of x and y, that is 1 and 2. Now we are going to get what? This is equal to minus 2 and minus 2 is minus 4, very simple, upon 2 to the 4 plus 1 is 5. So minus 4 upon 5 is our correct answer, which is option number B. I hope the concept is clear. Now let's move towards question number 3. So here comes our question number 3, which states which of the following statements is true regarding the implicit differentiation. Now let's understand the first option. It only applies to the linear function. No, it is not. It helps find derivatives when y is explicitly defined in terms of x. No, because implicit functions are what? Implicit functions are those functions where we can't isolate y. It is used when y is defined implicitly in terms of x. Fourth one is it cannot be used for composite functions. So which of the following statement is true regarding this? It is used when y is defined implicitly in terms of x only. So this is our option which is correct. That is option number C. Now let's move towards question number 4. So students, here comes our question number 4, which states what is the second order derivative d square y by dx square if dy by dx equals to this. So this is very important. You have to check what it is given here, because it is not y, it is given dy by dx. So obviously derivative of this particular function will give you d square y by dx square. So we can say that option number D, this C, you can check this particular option. This states the derivative of the given function is the second order derivative. Very simple. So option number D is our correct answer here. Now let's move towards question number 5. So students, here comes our question number 5 of this case study. Which of the following curves is defined implicitly? So as we discussed, what is the implicit functions where y cannot be separated from x. Here it is already separated, here also it is already separated, but in option number C you can see that x square plus y square is given. So therefore option number C is our correct answer here. So students, that was the last question of this particular case study. I hope you enjoyed this particular video and it is going to help you enhancing your skill how to tackle these case study. I have also prepared online test on different chapters which is also available on our website, which is udgamwelfarefoundation.com, and these resources are free of cost, and these online tests are going to help you out in how to tackle one marker question in your board exam, which comprises of 20% of the weightage of entire board exam. I am going to share the link in the description box. It is going to help you out in understanding these concepts on different chapters. So that was all in this particular video. We are going to meet in our next videos. Till then, goodbye and take care.